Okay, once again, hi to the guys at TEEP. They gave me a couple of ideas as to what's happening here. One of them was that the way it's wired up, it's looping from the power supply straight through the bridge rectifier and into the battery. So the way we can check that, I guess, is, as you can see, this yellow wire here goes to the battery, the other black wire is going to the negative of the power supply. So of course, if the voltages are different from the battery and the power supply, we'll get not only a current draw, but the voltage should go up in the battery as well. So hooking that on there, we can see the power supply has gone up to 520 milliamps, and the battery voltage is also going up. So that's just to show you that if it was bleeding through the setup I've got here, we would get a similar effect. So if I hook power supply up to the motor, and it was a loop circuit, we should be getting a current draw from the power supply, which we're not. The battery voltage also hasn't gone up, and there's not even 1 milliamp going through the system from the power supply to the battery. So I know it looks like it's a looped circuit. You can see the negative, or the earth, comes through to the negative side of the bridge rectifier, then the positive is coming through into one of the AC points. So you would think that it would bleed through into the cap. Now I've added a cap here because I was told by my stepfather, the electronics guru, that even analog meters don't like pulse DC. He said I would be getting a false reading to put a cap in line to smooth the pulses out, which I've done. As you'll see shortly, that has definitely changed things. Getting back to the loop circuit, well, like I said, it's hooked up now. It's drawing absolutely nothing out of the power supply. There's nothing going through in the way of amps, not even a milliamp. The battery is still 1175, so that's just to show you that it's not a looped circuit. Now the other thing was the back EMF is not being collected due to the way I've got it set up. So what we'll do now is we'll start the system, because I want to show you what the amps are doing on the meter now with the cap in place to smooth out the pulses. And it turns out that my stepfather was right, as he should be. So we're starting the system. Also, I've gotten rid of the little LED, and I've put a 6-volt battery in its place. And it was at 5.9. It's already starting to flick up and down. 5.92, 5.93. So that's actually charging. We're still drawing our 10 milliamps from the system, but now that I've put this cap in, smoothed the pulses out, we've gone up to about 32 milliamps that we're putting into the battery. As you can see, the battery was 11.75 when we started. It's already at 11.83 and climbing. Now, there was another idea about measuring the total input It was suggested that you have to let the battery rest, use that voltage. Talking to my friend who happens to be an auto sparky, he suggests that it doesn't matter what the voltage of the battery drops back down to, it's always voltage going in times current going in. So I'm only going on what he says. That makes sense to me. If you're putting in your 32 milliamps at 11.84 volts, that's what the system is putting into the battery. Now, whether the battery drops down after that, well, that's not taken into account. He said it's the amount of voltage and amperage that is being pushed into the battery at the time. So still drawing, we're flicking between 1 and 2, so that means very close to 19-20 milliamps at the moment, because I did wind it up a little bit more, but that's okay. We'll add that in with the calculations. Still on 32 milliamps going in. The battery's still climbing, flicking between 84 and 85, 11.84, 11.85. So I guess you guys could do the calculations on that. Like I said, was flicking up between 1 and 2, 10 and 20. So let's say 12 volts at 20 milliamps. I'll just write that down for my own purposes as well. 12 volts at 20 milliamps going in, coming out. It's moving between 28, 31. So we'll go to the lowest one, 28 milliamps, 11.84 volts. 11.84. Now we're not going to worry about this battery. It's climbing fairly slowly, so there'd be really nothing going in there, I'd say. Not a lot anyway. It is climbing. I guess you could charge it if you're going to have a machine like this running for a long time, but I'm more interested in what I'm putting in and what I'm getting out. So yeah, it climbs up and down for some reason. I'm not sure why. This climbs up, the motor starts to slow down, the motor starts to slow down, milliamps, it's climbing right up now, the milliamps drop down, and then the motor starts speeding back up again. So the battery is now at 11.87, so you can see it's definitely going up. Now the other thing was the back EMF. So because I've got that cap in there now, we can check this quite easily simply by disconnecting it from the battery. If there was no back EMF, I'm guessing it wouldn't go up any higher than the voltage being supplied by the power supply. So we'll disconnect the power from the machine that's going into the charge battery, so we can run the voltage test straight off the cap, and we'll see what happens. Well, there you go. It's going up very fast. The cap is a 2200 UF cap, 25 volts, so I'm not going to let that go too much higher. So, like you know, it's only 12 volts going in, 18, it's climbing, up, down. I've disconnected the motor, the charge battery. The motor's speeding up a little bit. still sitting on somewhere between 10 and 20 milliamps. We're going to go on 20. 19.43. I'm guessing if it wasn't collecting the back EMF from the coil, this wouldn't be going up this high. If anyone can explain why I would get 19.5 volts out and only put 12 in without there being some sort of transformer, that would be handy. Like I said, I'm still learning. So yeah, about 19.54. There is only 260 turns on that coil of 0.6 millimeter wire. Let's put this battery back up. The amp gauge has gone right off the scale now because the motor's picked up speed. Slowing down. So anyway, that's just to show you basically that the system isn't bleeding from the transformer through the system and into the charge battery. There's not much more I can tell you or explain. So yeah, we'll do some math on that. Like I said, we took it up to the 20 milliamps because it was somewhere between 10 and 20. It's drawn a little bit more since I put that cap in. 28 milliamps out at 11.5 or 11.84 volts. So there you have it. I'll leave it up to you guys to chew it over and see what you think.